Let's work with another piecewise function and identify if it's continuous at x equals 3. To do that, we need to figure out what is happening on the left from 3 and on the right from 3 and at 3. Again, as always, I will number all parts or pieces of the piecewise function and make a quick sketch for myself. I like doing that. Something is happening at 3. What is happening? When we are on the left from 3, so x is less than 3, then we have to work with equation number 1 because x is less than 3. When x is greater than 3, where should I look? Oh, equation number 3. So you see that will help me to know where to look. And at 3, I will work with equation number 2, whatever it is, and in that case it's just a constant, that x equals to 3. Let's start. I want to work with side limits first. So, what is the limit of the function when x approaches 3 from the left? Well, there are 3 choices of the function, of this piecewise function, to use here to substitute 3 in. Which one should I do? Well, now I know how to choose. When x approaches 3 from the left, it looks like so. X approaches values of 3, but less than 3, so it's from the left. In general, by the definition, that means that x is less than 3, but very close to 3. Thus, I will use equation number 1. Equation number 1 is negative 7x. And this is the only time you need to use this sign of the side limit. That's it. It just helps you to choose the equation to use for the limit. After that, you can substitute 3. 7 times 3 is 21, so it's negative 21. Very nice. Now, let's repeat it for the limit from the right. Limit of f of x when x approaches 3 from the right. This plus sign doesn't mean that 3 is positive or something like that. It just helps me to choose which equation to use for calculations. When x approaches 3 from the right, it means it's getting closer to 3, but a little bit larger than 3. So basically, I can say that x is larger than 3. From my sketch, or literally from this notation that x is larger than 3, I know that I need to choose equation number 3. Do you agree with me? And that's all. After this, I need to substitute 3 into the equation I have to work with. In this case, it is 7x. 7 times 3 is 21. Answer number 1, answer number 2. So, from these 2 answers, I already can tell that then limit at the point 3 of f of x does not exist. Because by definition, it exists only if left limit equals to the right limit, and they did not meet. This identifies a jump. Jump is a type of discontinuity. So I can say that f of x is not continuous, or it's discontinuous at x equals to 3. Moreover, it has a discontinuity called a jump at this point x equals 3. Let me show you a sketch. So, at 3, function on the left of 3 goes down to negative 21. It's literally the height. It's going down to negative 21. Symmetrically, it's going up to positive 21. So it's y equals 21 and y equals negative 21 at 3. Thus, it's jumping from the height negative 21 to the height positive 21. Hence the name. I wonder what is happening at 3. At x equals to 3, f at 3 is doing what? Let's go back and look at the equations. At 3, it actually equals to 1. Very interesting. That means that both points, so let me write down, it is 1. It means both points should be open from the left and from the right of 3 on the height levels, so it's y-axis. But I need to close a point at 1. At 1, y equals to 1. Function exists. So function exists at 3, and it is 1. Very interesting. So this is the sketch of the function we are working with right now. Do you think I should fix anything about my graph? I actually can try to figure out what is happening with this function. Is it a line? Is it a parabola? A sine function? Oh, but they both are lines. Here you go. So y equals to negative 7x and y equals 7x are just lines. You can actually sketch them using any 2 points. For example, 0, 0, and 1, negative 7, and 1, 7. At 0, the first line is 0, and then at 1, it is negative 7, I think. So it's going down like so, has an open hole, and the side on the right is also going down like so, and has a hole at 3. The height of the hole on the top is 21. The height of the hole at the bottom is negative 21. And there is a filled-in point at 3 on the height 1. And here is the graph. Hopefully you're getting more familiar with piecewise functions. Don't be afraid of those functions. They have thousands of applications in the real-life world, including your electricity bills and rent, and taxes as well. Keep working hard.